In this video, we're gonna finish what we left from the last one. So we did graph the this function, the cosine of the arcsine of x. Now we want to graph the sine of the arccosine of x. Remember that given the unit circle, okay, we can write the equation of the unit circle, which is x squared plus y squared equals 1, as if we define some angle here, alpha, and this is my x because this is my point xy. So I can define x and y in terms of alpha because this is a right angle. So I can get, so x is cosine alpha and y is just sine alpha. And I can get cosine squared of alpha plus sine squared of alpha is 1. Okay? Now we want to graph this one, sine of the arccosine of x. What's the arccosine of x? It's a function, okay, that's defined from -1, 1 and to 0 pi, such that for each x it does associate the measure of the arc. Okay, where and how, let's see it. So here, this is my unit circle. So this is my domain, -1, 1, okay. I take any point here, any x, let's call this one x, and I project it here on the upper half circle. So this one here is my arccosine. Okay, so it's only this half circle because it's defined between -1, 1 and 0 pi. 0 pi is this one here. This is pi, this is 0. Okay, so assume now that I want to find the sine of some, okay, of some angle. So I want to graph the sine of the arccosine of x. Okay, so I know this result here. So this is going to be very beneficial. But before using this one, we want to compute the cosine of the arcsine of x. Okay, and most of the time we did compute that last time, but now we want to compute the cosine of the arccosine of x. We can do it graphically. So we did this one last time and we had a different thing, but for now we want to compute this one. Okay, so how to do this one? So take any x from -1, 1, project it on this upper half circle and compute its cosine. So let's say I took x from here, -1, 1, and I project it and I get this one. Now I want to compute, so I can think of this one as some angle. When I compute the cosine, I get what? I get x. So this one is x. Okay, graphically, without doing any work. Now we're going to use this one here. So now let's graph this one. What about the sine, okay, of the arccosine? How to do it? So starting from here, we're gonna let this angle alpha. So I'm saying this because we want to use this relationship here. So I'm gonna let alpha equal the arccosine of x. So I can use this one here and I can use this fact here. Okay, let's do this. So we have the sine squared of arccosine of x is plus the cosine squared of arccosine of x is 1. Think of this one as some angle. So that's what we said. So this is some angle, alpha or beta. So this is the one that I want to graph. So this one is what? This is x squared. So I have sine squared of the arccosine of x is just 1 minus x squared. Okay, let me write it nicely here. Sine squared of the arccosine of x is 1 minus x squared. The problem is, what is this arcosine? It has its values on where? On 0 pi. Take any x from here, from -1, 1. Compute its arcosine. It's gonna be on this interval, 0 pi. And what's the sign of the arcosine here? It's always positive. So the sign of the arcosine of x is always positive because the arcosine is in 0 pi. So the sign is always positive. So here, when I take the square root, I get just the sign of the arcosine of x is 1 minus x squared. And this is my function. Okay? Now, I can just say this is the graph because it's the way that we graph, or I can say, so the y is defined in, so x is defined in -1, 1, and it's this one here, square root of 1 minus x squared. If I want to do it, I can just go and graph it, and it's half circle. So this is the half circle that I get. So this is the function sine of the arcosine. This is the graph of it. Okay? This will end our video because we introduced a lot of new information, and I'm hoping that this helps.